The factory still stands at 1161 Buckeye Road in Lima, Ohio. 500,000 square feet of brick and overhead cranes in a city that grew up around its gates. For 150 years, this ground has produced America's heaviest things. The Allegheny locomotive that left these doors in 1941 weighed 600 tons. The M1 Abrams that leaves them now weighs 70. The same workforce, 2 centuries apart, building war machines on different rails. How does one Ohio town outlast every other heavy arms city in America? The story of Lima is more than a corporate chronicle. It's an autopsy of American heavy industry. As we uncover the full story of its dramatic rise and fiery fall, I want to hear from you. Which legendary company or forgotten factory should we investigate next? Drop your suggestions in the comments below. And if you love stories of industrial empires, brilliant innovations, and the fateful decisions that changed history, hit subscribe and turn on notifications so you don't miss what's coming. Before there was a factory, there was a crossroads. Lima sat in the flat northwest quarter of Ohio, where 2 rail lines crossed a wagon road in the middle of farmland that nobody outside Allen County had reason to visit. The Pittsburgh, Fort Wayne, and Chicago Railway came through in 1854. The Lake Erie and Louisville followed a decade later. Where rails met, towns grew. Lima grew. By 1870, the town counted around 4,000 people. Most of them farmed corn and wheat on the dark glacial soil that stretched to the horizon. A few worked the depots and freight yards. The rest ran the small businesses that fed the farmers and the rail crews. There was a foundry that cast plowshares. There was a sawmill that cut local oak. There was a machine shop on the south side of town that did light repair work for the railroads. Nothing about the place suggested that it would, within 30 years, be exporting locomotives to Australia. In 1869, 3 men bought that machine shop. Their names were James Carnes, Benjamin Agurter, and Lyman Gray. They were not visionaries. They were not industrialists. They were practical Ohio men who saw a small business that could be run profitably if you knew what you were doing. Carnes had experience in foundry work. Agurter understood machinery. Gray handled the books. They paid for the shop in cash and reopened it under a new name, the Lima Machine Works, and they got to work. Here's the thing about the early Lima Machine Works. It wasn't trying to make history. It was trying to make money. The shop produced stationary steam engines for sawmills, threshing equipment for farms, a day and small castings for the railroads that ran through town. Orders came in from local mills and shops. Orders went out by rail. The work was steady, the margins were thin, and the floor was a place where a dozen men could do useful work without much fuss. The founders were good at what they did. By 1875, the shop was profitable enough to hire more hands and expand the building. They added a forge, a boiler shop, and a small erecting bay where larger machines could be assembled. They began producing portable steam engines for use in the timber camps and quarries of the region. These were workhorse machines, reliable, simple, repairable in the field. The kind of equipment that made a small reputation grow. Reputation in industrial Ohio in the 1870s traveled along rail lines. A mill operator in Pennsylvania who needed a new engine asked the freight agent who he should call. The freight agent had heard of the Lima shop from a customer in Indiana who had been satisfied. The order came in. The engine went out. Another satisfied customer told another freight agent. The map of Lima Machine Works customers spread outward. Slowly, the way a stain spreads through cloth. By the late 1870s, the shop employed around 40 men. The buildings had been expanded twice. The product line had grown to include sawmill machinery, threshers, boilers, and a variety of small steam engines for industrial use. The founders had begun to think of themselves as more than a repair shop. They were beginning to think of themselves as manufacturers. Then, in 1880, a man walked into the shop with an idea that none of them had ever seen before. His name was Ephraim Shea, and he was a lumberman from Michigan. He was tall, bearded, and quiet, with hands that had spent 30 years working timber. He had a problem that he had been thinking about for most of those years. The problem was that conventional locomotives could not pull logs out of the woods. The track in a logging operation was not laid the way mainline track was laid. It was laid quickly by men in a hurry, on uneven ground that twisted and dropped and climbed grades that would have stopped a regular freight engine cold. The rails curved sharply around stumps. The ties were uneven. A standard rod-driven locomotive with its long wheelbase and its inflexible drivetrain would derail in 100 yards. Shea had built a prototype in his own shop in Herring, Michigan. It was strange looking. A vertical boiler offset to one side, a geared drive that ran from the cylinders to all the wheels through a horizontal shaft and bevel gears. Every wheel was powered. The wheelbase was short. The locomotive could climb grades that would defeat any rod engine, and it could do it on rails laid by a logging crew with a maul and a level eye. He had patented the design. He had built 3 of them himself. He could not build them at the volume that the timber industry was already demanding. He needed a manufacturer. He had asked around the rail trade for a shop that could build to his specifications and not steal his patent. Someone, somewhere, had pointed him at the Lima Machine Works. Carnes, Agurter, and Gray listened to him for an afternoon. They walked the prototype around in their heads. They asked the questions a good shop foreman asks. How was the gearbox housed? How were the bevel gears cut? What kind of wear could you expect on the drive shaft after 1,000 miles in a logging camp? Shea answered every question. He had been answering them for a decade in his own head before he answered them for anyone else. The Lima Machine Works signed a license agreement with Ephraim Shea in 1880. The terms were straightforward. Shea held the patent. Lima would manufacture to his specifications, pay him a royalty on every unit sold, and stamp his name on the locomotive's builder's plate. The first Shea locomotive built at Lima rolled out of the erecting bay in 1880. It was small, ungainly, and not particularly handsome. It looked like nothing else on rails. It sold immediately. The first buyer was a logging operation in Michigan. The second was a coal mine in Pennsylvania. The third was a quarry in Ohio. Within a year, Lima had orders it could not fill on the schedule the customers wanted. The shop expanded. New erecting bays were built along the Buckeye Road frontage. New machinery was brought in. The workforce grew from 40 men to 100, and then to 200. Picture this: Lima, Ohio, in the spring of 1884. A clear morning, mud in the streets, the smell of coal smoke from the locomotive shop drifting east on a light wind. A flat car sits on the spur outside the erecting bay. 6 men are lining a finished Shea onto its frame, working with chains and a hand-cranked winch. The locomotive is squat, vertical boilered. Alley painted a dark green that catches the morning light. On its builder's plate, brass letters read Lima Machine Works, Lima, Ohio. The men do not stop to admire it. They have 3 more on the floor behind them, and a freight schedule to keep, and a new order from a logging firm in Oregon that wants delivery by August. That was Lima in the early 1880s. A small Ohio shop building a strange-looking locomotive that nobody else in the country could build. The Shea was protected by patent. The license was exclusive. If you wanted a geared locomotive that could pull logs out of the woods on a track laid by a crew with a maul, you bought it from Lima, or you did not buy it at all. Orders came in from the Pacific Northwest first, because that was where the timber was. The forests of Oregon and Washington were the largest standing reserves of marketable softwood in North America. The terrain was vertical. The grades that needed to be climbed to reach a stand of Douglas fir were grades that no rod-driven locomotive could handle. The Shea could. Logging companies in Coos Bay, in Aberdeen, in Hoquiam, in Astoria ordered Sheas by the dozen. The cars left Lima eastbound on the freight, transferred to westbound trains in Chicago, and arrived at the Pacific coast 3 weeks later. Crews in the camps assembled them on temporary track and put them to work the same day. Then the orders came from Appalachia. The coal seams of West Virginia and eastern Kentucky required the same kind of locomotive: steep grades, sharp curves, hastily laid track. The shays climbed where standard engines could not climb. And they pulled coal cars out of hollers that had been considered uneconomic to mine. The Norfolk and Western and the Chesapeake and Ohio bought shays for branch line work. Independent coal operators bought them for direct service. Then, the foreign orders. A logging firm in Australia ordered 3. A copper mine in Chile ordered 2. A railway operating in the Canadian Rockies ordered 4 for grade work in the mountain passes. Lima Locomotives, built in a small Ohio town, began arriving at ports in Vancouver, in Sydney, in Valparaiso. The builder's plate that read Lima Machine Works, Lima, Ohio, began to appear in places none of the founders had ever seen and would never see. Here's the thing about that period. The Lima Machine Works was not just selling a locomotive. It was selling a category. There was the rod-driven locomotive, once which every major builder in America made, and there was the geared locomotive, which one shop in Northwest Ohio made. The patent had created a monopoly on a type. The market for that type kept expanding. Every new logging frontier, every new mining operation, every new branch line that needed to climb a grade or curve sharply was a potential customer. By 1888, the shop employed 300 men. The buildings now covered most of a block along Buckeye Road. The original machine shop, which had been a single building when Carnes and Agerter and Gray bought it in 1869, was now a complex of erecting bays, pattern shops, foundries, and boiler works. The shay was being produced in 3 sizes: a small 2-truck variant for short logging runs, a larger 3-truck variant for heavier work, a massive 4-truck variant for mainline grade service. The founders began to think about what came next. Carnes, Agerter, and Gray were now in their 50s and 60s. They had built something larger than they had originally intended. The shop had become a factory, and the factory had become a major regional employer, and the products of that factory were being shipped to 4 continents. The name Lima Machine Works no longer described what the business actually was. The business was a locomotive manufacturer. It needed a name that said so. In 1892, the company was reorganized and renamed. The new name was the Lima Locomotive and Machine Company. The original founders sold most of their equity to a group of investors that included men with deeper capital and longer commercial vision. Carnes remained on the board. Agerter retired. Gray died of pneumonia in the winter of 1893 and never saw what the company became. The reorganization was not a hostile takeover. It was a recognition that the founders had built a shop, and what was needed now was a corporation. The new ownership invested in expansion. They purchased adjacent land along Buckeye Road. They built a new erecting shop with overhead cranes capable of handling locomotives of 100 tons. They expanded the foundry. They added a pattern storage building to hold the wooden molds for every shay variant in production. By 1900, Lima Locomotive and Machine Company employed nearly 1,000 men. The shay had been refined through 5 major design revisions. The largest variant, the 4-truck Class C shay, weighed over 150 tons and could pull a loaded log train up a 6% grade at 5 miles an hour, which was a feat that no other locomotive on Earth could match. Let that sink in. A small Ohio machine shop, founded by 3 men with no industrial pedigree, was now manufacturing a class of locomotive that no competitor could replicate. The patent that had started it all was nearing its expiration. When it expired, other builders would be free to make geared locomotives. By the time they got into the market, Lima would have a 20-year head start in design, manufacturing, and customer relationships. The founders had built something that could outlast them, And in the next century, the men who took over the company would push that something into territory that even Carnes, Aegerter, and Gray could not have imagined. The man who would push Lima into territory the founders could not have imagined arrived in 1916. His name was William Woodard, and when he walked through the gates on Buckeye Road that fall, he was already one of the most respected steam locomotive engineers in America. He had spent 20 years at the American Locomotive Company. He had designed Pacifics, Atlantics, and Mikados for half a dozen major railroads. He had patents on superheaters, on valve gear, on firebox design. He was 43 years old when he came to Lima, and he had not come to maintain an existing line of products. He had come because Lima had asked him to build something new. The new ownership group that had reorganized the company in 1892 had grown ambitious in the years since. The Shea had carried the business through the turn of the century, but the patent had expired in 1898, and competitors had finally entered the geared locomotive market. Climax and Heisler were now building geared locomotives of their own. Lima still held the lead in design and reputation, but the easy money was gone. The company had begun building rod-driven locomotives as well, switchers and small road engines for short-line railroads. The work was steady, but unremarkable. Lima was now one builder among many. The board wanted to be more than that. They wanted to compete with Baldwin and Alco, the two giants of American locomotive manufacturing. Baldwin built thousands of locomotives a year in Philadelphia. Alco built thousands more across its plants in Schenectady and Pittsburgh and Brooks. Together, they controlled the mainline market. To take a share of that market, Lima would need a chief engineer who could design something that the giants could not match. Woodard arrived with a thesis. He believed that American steam locomotive design had reached a plateau. Locomotives were getting bigger, but they were not getting better. A bigger boiler did not automatically mean more useful power. What mattered was how efficiently you could get steam to the cylinders, how completely you could burn the coal, and how much of the resulting energy you could turn into pulling force at speed. Most American locomotives, he argued, were oversized at the firebox and undersized at the steam circuit. They could pull, but they could not pull fast. The railroads were beginning to notice the same thing. Freight traffic in the 1920s was growing. And the railroads needed locomotives that could handle heavy trains at speeds that kept up with passenger schedules. A locomotive that could pull 80 cars at 30 miles an hour was less useful than a locomotive that could pull 80 cars at 50. Woodard called his design philosophy superpower. The name was inelegant. The concept was not. He proposed to redesign the steam locomotive from the firebox forward, optimizing every component in the steam circuit for sustained high-speed pulling. A larger firebox with a four-wheel trailing truck to support it, a boiler engineered for high steam generation rates, a feedwater heater that recovered exhaust heat, improved superheaters that produced drier, hotter steam at the cylinders, a higher capacity tender to feed it. The result, he predicted, would be a locomotive that produced more drawbar horsepower at speed than anything currently running on American rails. The board listened. Then, they let him build it. The first superpower locomotive emerged from the Lima erecting shop in February 1925. It was a 284, meaning 2 pilot wheels, 8 driving wheels, and 4 trailing wheels. The trailing truck designed to carry the larger firebox that Woodard's theory required. Lima named it the A1. It was experimental, owned by the company itself, intended as a demonstrator. Woodard wanted to put it in front of the railroads, run it on their lines, and let the data speak. The Boston and Albany Railroad, a New York Central subsidiary that operated the punishing Berkshire Hills grade in western Massachusetts, agreed to test the A1 in the summer of 1925. The Berkshire grade was famous in the railroad business for braking locomotives. It climbed and dropped through hills that demanded constant heavy pulling, with curves that punished any locomotive that could not handle the terrain. The Boston and Albany used two 8-2 Mikados on the line. Two Mikados, in fact, one pulling, one pushing. Even with that combination, the line averaged 23 miles an hour over the grade, with a typical freight train. The A1 ran the same grade with the same trains alone. It averaged 35 miles an hour. It hauled tonnage that had previously required two locomotives. It did so while burning less coal per ton-mile than either of the Mikados it replaced. The Boston and Albany's operations department reviewed the data, looked at each other across a conference table in Albany, and ordered 25 of them. The 284 wheel arrangement was named the Berkshire after the grade where it had proven itself. The name stuck. Every 284 built in America for the next 30 years would be called a Berkshire, regardless of who built it. Here's the thing about the Berkshire. It did not just sell to one railroad, it sold to dozens: Erie, Nickel Plate, Père Marquette, Boston and Maine, Chesapeake and Ohio. Each of those railroads had grade territory that needed the kind of sustained pulling power that Woodard's design produced. Each of them placed orders. Lima built Berkshires through the late 1920s and into the 1930s at a pace that the old Shea-era shop could never have accommodated. The Buckeye Road plant expanded again. New erecting bays were built to handle locomotives of 200 tons. The forge was rebuilt with steam hammers capable of working larger castings. The pattern shop grew into its own building. By 1929, Lima Locomotive Works employed roughly 6,000 men across 3 shifts. And the production floor ran around the clock during peak periods. Picture this: Lima, Ohio, in the fall of 1929, 6 o'clock on a weekday afternoon. The day shift has just been relieved, and the men are walking out through the main gate on Buckeye Road, tin lunch pails in hand, faces dark with coal dust and machine oil. A line of automobiles waits at the curb to pick them up. Wives stand on the sidewalk. Children chase each other along the brick wall of the foundry. The shift whistle has stopped blowing, but the noise from inside the plant has not changed. The next shift is already at the machines. A finished Berkshire sits on the spur outside the erecting shop, painted black, the boiler still warm from its first fire. Tomorrow it will leave for delivery to the Père Marquette in Michigan. Tonight it sits under the falling autumn light, while the men who built it walk past it on their way home. Downtown Lima, 3 blocks away, the bars on Market Street are filling up. Workers from the foundry shift drink beer at the bar of the Hotel Argonne. The pizza shops on West High Street are taking phone orders for the night shift dinner runs. The Methodist Church on Elm Street holds its choir practice at 7, scheduled around the shift change so that the singers from the plant can attend. The town and the factory have become the same circulatory system. The pulse of one is the pulse of the other. And that was Lima at the height of its golden age. 6,000 workers, the largest employer in Northwest Ohio, building locomotives that the largest railroads in America were ordering by the dozen. The town's tax base, its retail economy, its school enrollments, its property values all rose and fell with the order book on the manager's desk inside the Buckeye Road plant. The men who built the Berkshires knew they were building something special. They could feel it in the weight of the castings, in the precision of the valve gear, in the way the finished locomotives looked when they sat outside the erecting bay waiting for delivery. The Berkshire was not just a product. It was the proof that a small Ohio works could outthink the giants. Baldwin had been building locomotives for nearly a century. Alco had 8 major plants. Lima had 1. And Lima had built the locomotive that defined an era. What none of them knew yet was that the locomotive that defined an era was also a locomotive entering its final decade. The Berkshire was the beginning of superpower, not its conclusion. Through the late 1920s and into the 1930s, Woodard and his engineering staff applied the same design philosophy to one wheel arrangement after another. The 464 Hudson, optimized for high-speed passenger service. The 484 Northern, a heavy dual-service locomotive that could pull freight or passenger trains with equal ease. The 210-4 Texas, a mountain-grade hauler with 10 driving wheels and a 4-wheel trailing truck large enough to support a firebox the size of a small room. Each of those designs found buyers. The Erie Railroad ordered Berkshires and Hudsons. The Nickel Plate Road, which ran fast freight between Buffalo and Chicago, ordered Berkshires by the dozen and made them the backbone of its mainline operations. The Père Marquette, which served Michigan's lumber and automobile industries, ordered Berkshires for its main lines. The Boston and Maine ordered them for New England service. The Chesapeake and Ohio ordered Texas-type locomotives for its Allegheny coal hauls. Lima's order book in those years read like a directory of major American railroads. Not all of them were customers, but enough of them were that the company had become, alongside Baldwin and Alco, one of the three locomotive builders that mattered. The big three of American steam manufacturing. Baldwin was largest, Alco was second, Lima was third. But Lima was the design leader. Lima was the works that other engineers came to study. Engineers from foreign railroads visited the Buckeye Road plant in those years. A delegation from the South African Railways came in 1928. A team from the Argentinian State Railway came in 1931. The Soviet government, then in the middle of its first 5-year plan, sent a technical mission to study American locomotive manufacturing in 1932, and Lima was one of 3 plants on the itinerary. The Lima foreman who walked the Soviet delegation through the erecting bay later told a Lima News reporter that the visitors had asked the same question at every station. How long does it take to assemble one? The answer, depending on the model, ran from 6 weeks to 4 months. The Soviet engineers wrote everything down. Inside the plant, the work had a rhythm that men who had spent 20 years on the floor could feel without looking at a clock. The forge struck on the same beat every minute. The overhead cranes moved on schedules that the riggers could call out without checking the day's plan. The machine shop ran 2 shifts on weekdays and 1 on Saturday. The foundry poured at 3 in the afternoon. The erecting bay rang with the sound of pneumatic riveters from 7 in the morning until 5 in the evening, 6 days a week. Here's the thing about Lima in the early 1930s. The Great Depression that crushed industrial production across America hit the railroads hard, and the railroads were Lima's only customer. New locomotive orders fell sharply between 1930 and 1933. The Buckeye Road plant ran on reduced shifts. The workforce dropped from 6,000 to roughly 3,000. The town of Lima felt every layoff. Storefronts closed on Market Street. Property values dropped. The school district cut teachers. But Lima did not die. The orders that did come in were for high-end superpower locomotives, the kind of locomotives that Baldwin and Alco could not match on design merit. The Nickel Plate placed an order for 15 more Berkshires in 1934. The Erie Railroad ordered 10 Berkshires in 1935. The Père Marquette ordered 8 Berkshires in 1937. Each order kept the plant running. Each order proved that even in a depressed market, the railroads that wanted the best locomotive available knew where to buy it. By the late 1930s, the steam locomotive business in America had reached what the trade press called maturity. Designs had been refined to the point where dramatic improvements were unlikely. Boiler pressures had climbed as high as metallurgy allowed. Firebox dimensions had grown as large as practical. Drivers had grown to 7 feet in diameter for high-speed service. The locomotives being built in 1939 were larger, faster, and more efficient than the locomotives of 1925, but they were locomotives of the same fundamental type: a coal-fired boiler, generating steam, driving cylinders, turning wheels. Then, in November 1939, General Motors put a different kind of locomotive on a continental tour. The locomotive was called the FT, and it was a diesel-electric. It had no boiler. It had no fire. It burned diesel fuel in a piston engine, which turned a generator, which produced electricity, which drove traction motors mounted directly on the wheels. The whole package was housed in a streamlined steel body that looked nothing like a steam locomotive. It came in 4 units permanently coupled together, each producing a combined 5,400 horsepower. It could run for hundreds of miles without a fuel stop. It required no water at all. General Motors, which had bought the Locomotive Corporation in 1930, sent the FT on a coast-to-coast demonstration tour through the railroads of America. The locomotive arrived at the yards of major railroads, ran trial runs with their crews, and produced operational data that the railroads had never seen from any locomotive they owned. Fuel consumption per ton-mile was roughly half that of the best superpower steam. Maintenance costs were a fraction. The diesel-electric could be refueled in minutes. It could be taken from cold to running power in a few minutes more. It did not need a roundhouse turntable. It did not need water tanks at every division point. It did not need the army of boilermakers, hostlers, ash pit men, and machinists that a steam locomotive demanded just to keep it operational between runs. The railroads that hosted the FT looked at the data, looked at each other across operations conference tables, and began to recalculate everything they thought they knew about motive power. Here's the kicker. Lima saw the FT. Woodard was still active as a consulting engineer in those years, and the Lima engineering staff had access to the same trade press and the same operational reports that everyone else in the industry had access to. They knew what the FT meant. They knew that a locomotive that burned half the fuel and required a fraction of the maintenance was going to win the long-term economic argument against any steam locomotive ever built. And Lima did nothing about it. The reasons were not stupid. They were the reasons that any successful business gives itself for not changing. Lima was an expert in steam. Its workforce knew steam. Its tooling was built for steam. Its engineering staff had spent 30 years refining steam. To pivot to diesel-electric production would mean rebuilding the plant, retraining the workforce, and competing against General Motors, which had 10 years of head start in diesel-electric design, and a parent company with manufacturing resources that no independent locomotive builder could match. Easier to keep building what you knew how to build. Easier to bet that the railroads would want one more generation of bigger, better steam. Then, on December 7, 1941, the United States entered the Second World War, and for 4 years, the question of steam versus diesel was suspended. The federal government's War Production Board took control of locomotive manufacturing and rationed every ton of steel and every locomotive built. The board needed motive power immediately, and it needed it in volumes that no peacetime market could justify. The diesel-electric was a new product, expensive, and dependent on a specialized supply chain. Steam was proven, cheaper per unit, and could be produced by every existing plant. The board ordered the railroads to keep buying steam. Lima built locomotives at full capacity through the war years. The Buckeye Road plant ran 3 shifts. The workforce climbed back to 6,000 and then beyond. The orders that came in during the war were the orders that allowed Lima to design and build the largest steam locomotive it had ever built. That locomotive was already on the drawing board. It was scheduled for delivery to the Chesapeake and Ohio Railroad in 1941. It was the locomotive that would prove every theory of superpower steam at the largest scale ever attempted, and it would roll out of the Buckeye Road erecting bay just as the world was deciding that the era of steam was already over. The Chesapeake and Ohio had been moving coal out of the West Virginia mines for 60 years by the time it asked Lima for the largest steam locomotive ever built. The railroad's main line ran from the coal fields of southern West Virginia through the Allegheny Mountains to Tidewater at Hampton Roads. The grade through the mountains was the operational bottleneck of the entire system. Heavy coal trains required helper locomotives at the bottom of the climb, and even with helpers, the trains moved slowly and consumed enormous quantities of fuel and crew time. The C&O's chief engineering staff had concluded that what the line needed was a single locomotive capable of pulling a heavy coal train over the grade without help. Lima accepted the contract in 1940. The specifications were extreme. The locomotive was to be a 2-6-6-6, a wheel arrangement that meant 2 pilot wheels, 6 driving wheels on a forward articulated set, 6 more driving wheels on a rear set, and 6 trailing wheels supporting the largest firebox ever fitted to an American locomotive. The total weight of engine and tender combined would exceed 700 tons in service. The boiler pressure would run at 310 pounds per square inch. The horsepower at the drawbar would exceed 7,500 at speed. Woodard, by then in his late 60s, supervised the design from his consulting role. The plant tooled up for the largest castings it had ever poured. The cylinder block alone weighed 35 tons. The boiler shell required steel plates so thick that the boiler shop had to be modified to handle it. The driving wheels were 6'6" in diameter, and each one weighed more than 7 tons. The first locomotive was named the H8 in C&O service. Lima called it the Allegheny, after the mountains it was built to climb. The first unit rolled out of the erecting bay in December 1941, 3 weeks after Pearl Harbor. Picture this: Buckeye Road, Lima, Ohio, the morning of the Allegheny rollout. December cold. The kind of cold that turns the breath of the men outside the erecting bay into white columns that rise and disappear in the still air. The wide doors of the bay are pushed open. Inside, the locomotive sits on the assembly track, painted black. The boiler cladding still bright with new paint. The C&O Herald stenciled on the cab side in white. 2 switchers are coupled to the front to pull it out. The yard foreman gives the signal. The Allegheny rolls forward into the daylight. 6 driving wheels on each set turning slowly, the connecting rods catching the morning sun. Around the perimeter of the yard, men have stopped their work to watch. Pattern makers from the foundry, riveters from the boiler shop, machinists from the cylinder line. Several hundred of them stand silent along the brick walls and on the loading docks while the locomotive moves out into the inspection track. Nobody cheers, nobody shouts. The locomotive moves past them in absolute silence, except for the slow grind of its wheels on the rail and the hiss of steam from the safety valves. The men watch it pass. They built it. They know what it is. They know it is the largest, the most powerful, the most refined steam locomotive that the American industry has ever produced. They also know that something is wrong, not with the locomotive itself, and with the world it is being delivered into. None of them say it out loud, but several of them remember the General Motors demonstrator that ran past Lima in 1939, and they understand that the Allegheny is being built into a market that is already turning toward something else. 60 Alleghenies were eventually built for the C&O between 1941 and 1948. The locomotives performed exactly as Lima had promised. They pulled 14,000-ton coal trains over the Allegheny grade without helpers, at speeds that the old 2882 mallets could never match. They consumed coal and water in proportion to their work, and the work they did was prodigious. They were, by any measure of steam locomotive performance, the finest heavy mountain locomotives that ever ran on American rails. They were also obsolete on the day they were delivered. The war years masked the obsolescence. The War Production Board's restrictions on diesel-electric production held the diesel revolution at bay until 1945. Lima and the other steam builders ran at capacity. The Buckeye Road plant produced Berkshires and Hudsons and Texas types alongside the Alleghenies, building locomotives for the Erie, the Nickel Plate, the Père Marquette, and the Norfolk and Western. The plant also produced wartime work that had nothing to do with locomotives: naval gun mounts, tank components, heavy castings for shipyards on both coasts. The same forge that hammered locomotive frames hammered military hardware. The same machinists who turned drive wheels turned breech blocks for naval artillery. That wartime work was important. The men who did it would remember it later. It was the first time that the Lima Locomotive Works had built things other than locomotives at scale, and the institutional knowledge it created would matter in the next chapter of the company's history, though nobody knew it yet. When the war ended in August 1945, the rationing on diesel-electric production ended with it. General Motors' Electromotive Division, freed from the War Production Board's restrictions, returned to full-scale production of diesel-electric locomotives. Alco had begun building diesels under license. Baldwin had begun building its own. By 1947, every major American railroad was placing orders for diesel electrics, and the orders were not for trial units. They were for replacements of entire steam fleets. The numbers were brutal. In 1945, the American railroad industry operated roughly 40,000 steam locomotives and roughly 2,000 diesels. By 1950, the steam fleet had dropped to about 30,000, and the diesel fleet had grown to about 15,000. By 1955, steam was below 15,000, and diesel was above 30,000. The transition was not a slow conversion. It was a stampede. Here's the thing about that stampede. Lima could see it happening. Every shipping report, every railroad annual report, every issue of Railway Age confirmed what was happening. The orders that the company had counted on, the orders for the next generation of superpower steam, did not come. The Allegheny order from C&O finished in 1948. The Berkshire orders from the nickel plate had finished in 1949. New steam orders from any railroad were a trickle, and then nothing. Lima made a late attempt to enter the diesel market. The company designed and built its first diesel-electric switcher in 1949, a 1,000-horsepower unit intended for yard service. A handful of road switchers followed. The locomotives were competent. They were not better than the diesels that EMD and Alco and Baldwin were already producing in volume, and they did not establish a market position that could compete with builders who had been refining diesel-electric design for 15 years. Lima had entered the diesel market a decade too late. In 1947, recognizing that its own resources were not sufficient to compete in the diesel transition alone, the Lima Locomotive Works merged with the General Machinery Corporation of Hamilton, Ohio, a builder of marine engines and industrial equipment. The combined company was renamed Lima Hamilton Corporation. The merger gave Lima access to General Machinery's diesel engine technology and manufacturing base. It gave General Machinery access to Lima's locomotive expertise and customer relationships. Lima Hamilton built diesel-electric switchers and road switchers from 1949 through 1951. The total production was modest, roughly 200 units. The locomotives sold to short-line railroads and industrial customers, primarily in the Midwest. They did not sell to the major Class I railroads that Lima had built Berkshires for in the 1920s and 1930s. Those railroads had already placed their orders with EMD or Alco. Their motive power decisions were made. The diesel locomotive line at Lima Hamilton lasted 2.5 years. It was not enough. The last commercial steam locomotive Lima ever built rolled out of the Buckeye Road erecting bay in May 1949. It was a Berkshire, ordered by the Nickel Plate Road as part of a final group of 15 units that completed the railroad's wartime expansion of its mainline fleet. The locomotive carried Nickel Plate Road number 779. It was, by the time it was finished, an anachronism. The nickel plate already operated diesel-electric switchers in its yards. The other major railroads were ordering diesels for road service. The 779 was the last new steam locomotive that Nickel Plate would ever buy, and it was the last new mainline steam locomotive that Lima would ever build. Picture this: Lima, Ohio, the morning of the 779's delivery, a weekday in late spring. The locomotive sits on the spur outside the erecting bay, painted black. There, the nickel plate herald stenciled on the cab. 3 men stand on the running board doing final inspection. A handful of older workers from the boiler shop stand on the loading dock, watching. They built Berkshires for 24 years. They know the design as intimately as a man knows the road he grew up on. They watch the 779 the way a man watches a friend leave on a journey from which there is no return. Nobody says anything. The yard switchers couple to the front of the locomotive. The 779 is pulled out of the yard onto the nickel plate interchange track, and within the hour, it is gone. The men on the loading dock turn and walk back into the shop. That was the end. There was no ceremony. There was no announcement in the local paper. There was no farewell speech from the plant manager. The last steam locomotive ever built at Lima Locomotive Works left the yard on a regular Tuesday, and the men who built it went back to their machines because there was still diesel work to finish on the floor. In 1951, Lima Hamilton merged with the Baldwin Locomotive Works of Philadelphia. The combined company was named Baldwin Lima Hamilton Corporation. Baldwin had been the largest American locomotive builder for over a century. By 1951, Baldwin was also losing the diesel-electric race, and the merger was a defensive consolidation between 2 builders who hoped that combined resources might allow them to compete with EMD and ALCO. It did not. The combined company's diesel-electric production ran for 5 more years. The locomotives sold to a shrinking pool of customers, mostly short lines and industrial operators. The Class I railroads continued to buy from EMD and ALCO. By 1955, Baldwin Lima Hamilton had concluded that the diesel locomotive business was no longer viable for them. In late 1956, the company announced that it was exiting locomotive manufacturing entirely. The locomotive line at the Lima plant was shut down. The pattern shop, the erecting bay, the boiler shop, the foundry that had cast cylinder blocks for Berkshires and Alleghenies, all of them went silent. The Buckeye Road plant did not close. Baldwin Lima Hamilton kept the Lima facility operating for the production of construction equipment, mobile cranes, and shovels, which the Lima division had begun building in the late 1940s as a sideline. The cranes and shovels were good products. The Lima crane was a respected piece of equipment in the construction industry through the 1950s and into the 1960s. But the workforce required to build cranes was a fraction of the workforce that had built locomotives. By 1958, Lima employment at the Buckeye Road plant had fallen to roughly 1,500. By 1962, it was below 1,000. Let that sink in. A plant that had employed 6,000 men in 1929 building locomotives that the largest railroads in America were ordering by the dozen was now employing under 1,000 men building construction equipment. The town of Lima absorbed the loss, the way a body absorbs a slow injury. Storefronts on Market Street that had served the lunch trade of 3 plant shifts now served 2. The bars on West High Street that had filled at shift change stood half empty. The school district of Power adjusted its enrollment projections downward. Property values in the neighborhoods that had housed plant workers softened. Through the 1960s, the Lima plant continued to build construction equipment under a series of corporate ownerships. Baldwin Lima Hamilton sold the Lima crane and shovel business to Clark Equipment Company in 1971. Clark Equipment ran the operation for several years before selling it on. The plant produced industrial machinery for construction, for mining, for materials handling. The work was honest, the products were competent, but the scale was nothing like what Lima had been. The men who had assembled Berkshires in the 1930s had retired or moved on. The men who had built Alleghenies in the 1940s had retired. A new generation of workers came in, learned the construction equipment trade, and worked the same buildings their fathers had worked, building different products at smaller scale. The town survived. It did not thrive. Lima's population peaked at around 51,000 in 1960 and began to decline as the manufacturing base contracted. The county lost industrial jobs to plants in lower-cost regions. Young people who graduated from Lima Senior High School left for Toledo or Columbus or Cincinnati, where the work was. Older residents who remembered the plant at its peak grew accustomed to driving past the buildings on Buckeye Road and seeing them quiet, the parking lots half full, the shift whistles silent. Here's the thing about that period. The Lima plant was still there. The buildings still stood. The overhead cranes in the old erecting bay still worked. The foundry was still operational. The boiler shop, the machine shop, the pattern storage building, all of them were intact. The infrastructure of a major heavy manufacturing facility, built and refined over 80 years, was sitting on Buckeye Road producing construction equipment at a fraction of its capacity. That infrastructure was about to matter again, in a way that nobody in Lima could have predicted. In the late 1960s, the United States Army began a long and frustrating effort to develop a replacement for the M60 main battle tank. The M60 had entered service in 1960 and was, by the standards of the late 1960s, already aging. The Soviet Union had introduced the T-64 in 1964, and the T-72 was in advanced development. American intelligence assessments suggested that the next generation of Soviet armor would have firepower and protection that the M60 could not match. The Army's first attempt at a replacement was a joint program with West Germany called the MBT-70. The program ran from 1963 to 1971. It produced prototypes that demonstrated impressive capabilities and equally impressive cost overruns. The unit cost projection rose from $1 million to over $5 million over the course of the program. Congress canceled MBT-70 funding in late 1971. The Army was left without a tank replacement program and with 7 years of development time wasted. In 1972, the Army began a new program. This one would be entirely American. It would be designed to a strict cost target. It would emphasize crew survivability, firepower at standoff range, and operational reliability. The Army called it the XM1. By 1973, the Army had identified a problem that ran parallel to the design challenge. The country had only one operational tank manufacturing plant. That plant was the Detroit Arsenal Tank Plant in Warren, Michigan, operated by Chrysler Corporation under contract to the government. The Detroit Arsenal had been building tanks since the Second World War, and it was capable of producing tanks at the rates the Army had needed in the 1950s and 1960s. It was not capable of producing the volume that the XM1 program would require if the new tank was to replace the M60 fleet on the timeline the Army wanted. The Army needed a second production base. It needed a plant with heavy manufacturing infrastructure already in place, a plant with overhead cranes, with foundry capacity, with machining capacity, with a workforce that knew how to build large metal things to tight tolerances. A plant that could be retooled for tank production without being built from scratch. The Army's planners began to look at industrial sites across the Midwest. They looked at idle steel mills, at converted automobile plants, at heavy equipment factories. They looked at sites in Pennsylvania, in Indiana, in Ohio. They drew up a list of candidates and sent technical evaluators to each one. One of the sites on the list was a building complex on Buckeye Road in a small Ohio city that had once been the largest locomotive works in America. The Army's evaluators visited Lima in 1974. They walked the Buckeye Road property with clipboards and tape measures and a list of specifications that the candidate site needed to meet: overhead crane capacity, floor load ratings, foundry capability, machine shop capacity, rail spurs for delivery of raw materials and shipment of finished product, distance from population centers in case of accident, workforce availability within commuting distance. The Lima property checked nearly every box. The buildings had been engineered to handle locomotives weighing 200 tons. The cranes could lift 60 tons. The foundry could pour castings as large as anything the XM1 program would require. The rail spurs that had carried Berkshires out to the nickel plate could carry tank hulls in either direction. The workforce in Allen County included several thousand men with heavy manufacturing experience. The evaluators wrote their report in 1975. Lima was on the short list. In June 1976, the Army awarded the M1 production contract to Chrysler Defense, the defense subsidiary of Chrysler Corporation. The contract specified that Chrysler would produce the new tank at two facilities: the Detroit Arsenal Tank Plant in Warren, Michigan, which Chrysler already operated under government ownership, and a second plant, to be reactivated and retooled, at the former Lima Locomotive Works site on Buckeye Road in Lima, Ohio. The reactivation began in 1976. The federal government acquired the Buckeye Road property and designated it the Lima Army Tank Plant. The investment in retooling totaled approximately $400 million over 3 years. The existing buildings were stripped to their structural shells and rebuilt for tank production. New machine tools were installed. Robotic welding cells, advanced for their time, were brought in. The old foundry was modernized. The forge that had hammered locomotive frames was retasked to forge tank components. The overhead cranes that had lifted Berkshire boilers were retasked to lift tank hulls. The workforce came from Lima. Some of the men who walked into the new Lima Army Tank Plant in 1977 and 1978 had fathers who had built Berkshires. A few of the older ones had themselves worked the tail end of the locomotive era and the construction equipment years that followed. They knew the buildings. They knew the cranes. They had to learn tank manufacturing. But they brought with them the institutional knowledge of how to move large pieces of metal through a complex production sequence. The first prototype M1 Abrams tank was assembled at Detroit. The first production standard M1 was scheduled to roll off the Lima line in early 1980. Picture this: February 28, 1980, Buckeye Road, Lima, Ohio. A cold winter morning, gray sky, a thin wind out of the northwest. The wide doors of the assembly bay are pushed open. Inside, on the final assembly track, the tank sits painted in the standard Army drab. Its turret is locked in the forward position. Its tracks are tensioned. Its sponson covers are in place. A small group of men stand around it. A few Army officers from the program office, a handful of Chrysler executives in dark coats, the plant manager, the first shift foreman, the 4 assembly workers in coveralls who did the final inspection that morning. One of them is named Don Ridenour, a 46-year-old machinist whose father had worked the Lima boiler shop in the 1940s. Ridenour signs the inspection tag and clips it to the turret stowage box. The plant manager nods to the foreman. The foreman waves to the operator in the cab. The tank's gas turbine engine spools up with a sound nobody on the floor has ever heard before. Not the deep cough of a steam boiler, not the steady drone of a diesel switcher. A high, shrill whine that rises through the assembly bay and settles into a sustained turbine hum. The tank rolls forward off the assembly track and out through the open doors. The men watch it go. Several of them look at each other. Nobody says it out loud. But every one of them knows that they have just done something their fathers did in a different way, on the same ground. The first M1 Abrams to enter service had been built at the same address where the Allegheny had been built 39 years earlier. The Lima Army Tank Plant ramped up production through the early 1980s. The Cold War was at its peak. The Reagan administration had committed to a substantial expansion of the American armored force. The Army's projected M1 production requirement ran to thousands of units. Lima and the Detroit Arsenal together would build roughly 7,000 M1 and M1A1 tanks between 1980 and 1992. In March 1982, General Dynamics Corporation acquired Chrysler Defense, including the Lima operation, for approximately $348 million. Chrysler Corporation, under financial strain in the early 1980s, was selling off non-core businesses. General Dynamics, already a major defense contractor with submarine and aircraft programs, wanted to enter the armored vehicle business. The acquisition transferred operational control of the Lima plant from Chrysler Defense to a new General Dynamics subsidiary called General Dynamics Land Systems. The buildings did not change. The workforce did not change. The product did not change. The name on the door changed. Through the rest of the 1980s, Lima Army Tank Plant ran at high capacity. The M1A1 entered production in 1985 with improved armor protection and the larger 120mm smoothbore gun, replacing the original 105mm rifled gun. The plant ran 2 and 3 shifts, depending on the production schedule. Employment at the plant climbed back above 3,000. The town of Lima, after 25 years of slow industrial contraction, found itself once again hosting a major defense contract that hired aggressively from the local workforce. Here's the thing about that period. The men who walked through the gate at Buckeye Road in 1985 looked, in many ways, like the men who had walked through that gate in 1929. Tin lunch pails had been replaced with plastic ones. The cars in the parking lot were Fords and Chevys instead of Model Ts. But the rhythm was the same. 3 shifts. The whistle at change time. The bars on West High Street filling at the end of the day shift. The pizza shops taking phone orders for the night shift. The town and the plant, once again, were the same circulatory system. In January 1991, the M1A1 went to war for the first time. The Persian Gulf War, the campaign to expel Iraqi forces from Kuwait, was the operational test of every assumption American armor doctrine had made in the previous decade. The Lima-built and Detroit-built M1A1s engaged Iraqi T-72s in the largest tank battles since the Second World War. The results were lopsided. American crews destroyed Iraqi armor at standoff ranges that the Soviet-built tanks could not match, with a survivability rate that vindicated every dollar spent on the Abrams program. The men in Lima watched the news coverage and understood that the tanks they had built were performing in the desert. Through the 1990s, the plant continued to produce M1A2 variants with further upgrades. Export contracts came in. Egypt, Saudi Arabia, and other allied governments ordered Abrams tanks built at Lima. The export work kept the line running through periods when domestic army orders slowed. The plant is still there, still running, still building tanks for the United States Army and for foreign customers under approved sales programs. The factory at 1161 Buckeye Road still hums after dark. The same brick walls, the same overhead cranes, the same rail spurs. The men who built the Berkshires are gone now, and so are most of the men who built the first M1s. The workforce on the floor today is a generation removed from both. They walk through the same gates their grandfathers walked through. They build a different war machine on the same ground. The locomotives are gone. The tanks remain. The plant still hums.